Hi, this is Dr. O'Connor. Welcome to Pathways to Chemistry. This is an initial rate problem, and we're asked to write the rate law. So we're going to write that rate law in this form right here. So the rate is going to be equal to K times the concentration of nitrogen dioxide to some power, which is M, multiplied by the concentration of carbon monoxide to the N power. Now, the first thing I'm going to do is I note that for carbon monoxide in experiments 1 to 2, its concentration is held constant. So that will allow me to find M, or the exponent for the concentration of nitrogen dioxide. So I'm going to divide the rate of experiment 2 by the rate of experiment 1. So let's go ahead and write out the rate for experiment 2 is going to be equal to K, and we're going to multiply that by 0.15 to the M power, multiplied by 0.1 to the N power, and that's equal to 1.13 times 10 to the negative 2 molar per second. And then what I'm going to do is divide that by the rate of experiment 1, and that's going to be K times 0.1 molar to the M power, 0.1 molar to the N power, and that is going to equal 5.0 times 10 to the negative 3 molar per second. Okay, so we see that our K's cancel out here, and this also cancels out. So what I'm going to do is divide 0.15 by 1, and that is going to give us 1.5 to the M power, and then we'll go ahead and divide the rates here, and that is going to give us 2.26. So now what I need to do is, according to my properties of logs, I can write M times the log of 1.5 equals the log of 2.26, and what we end up with is, I'll go ahead and solve for M, log of 2.26 divided by log of 1.5, and we end up with M equal to 2. So we're second order with respect to nitrogen dioxide. Now, let's go ahead and determine the exponent for carbon monoxide. This is different from many of the problems that we've done, and the reason it's different is, notice that there are no two experiments where we've held the concentration of nitrogen dioxide constant. But that's okay, we can still solve for N. We'll look at experiments 1 and 3 in order to solve for N. So I'm going to set this up just like I did before. I'm going to have rate of experiment 3 divided by rate of experiment 1, and experiment 3 would be K, and that'd be 0.200 molar for the NO2, and we also know what M is, so that'd be to the second power, and then we would have 0.2 molar to the N power, and that would be equal to 2 times 10 to the negative 2 molar per second. I'll divide that by the rate of experiment 1, and here again we're going to have 0.1 to the second power, okay, and we multiply that by 0.1 to the N, and that's going to be equal to 5 times 10 to the negative 3 molar per second. So again, as before, we see that our K's cancel out, and nothing else cancels here, but that's okay, because I know that 0.2 divided by 1 is going to be 2, so that's going to be 2 to the second power for this part, and then here 0.2 divided by 0.1 again is 2, so that's going to be 2 squared times 2 to the n power. And then we divide these rates here, and that works out to be 4. Okay, so here what I have is 4. 2 squared is 4. So I'm going to go ahead and divide that both sides by 4. So I'm going to have 2n is equal to 1. And just looking at this, we see that n must be 0 because 2 to the 0 power is equal to 1. So n equals 0 in this case. So I can write my rate law as rate is equal to K, the concentration of nitrogen dioxide squared, concentration of carbon monoxide to the 0 power, and that is K times the concentration of NO2 to the 2nd power. So this is my rate. Remember, anything to the 0 power is just 1. So I hope this helps. Everybody have a nice evening.